It happens often, both in mathematics and in everyday life, that we need to bind objects together to create links between them. We bind the amount of pasta we're cooking to the amount of water needed. We bind a date and time to BlackBerry's stock price, or perhaps we bind tasks to how we feel about them. In the context of mathematics, these bindings are actually called relations. A relation attaches each starting element, say the element doing our taxes, to one or more results, say the elements boring and tedious, and can do so for all possible starting elements. A specific input to a relation is called the pre-image of that relation, while the outputs coming from that given element are called the image of the relation. The set of all possible starting elements, the set of all pre-images, is actually called the domain of the relation, while the set of possible results is called the range of the relation. You can think of the domain of a relation as a set of all possible inputs that can be stuffed into the relation, and you can think of the range as a set of all possible outputs that can come out of said relation. In our case, the domain of the feeling relation is the set filing taxes, cleaning dishes, and paying rent. The range of our relation is the set tedious, boring, relaxing, and panic-inducing. While many types of relations exist, there is a special type that is of interest to us: functions. Just like other relations, functions bind elements together. However, with functions, you can only bind an element of the domain to one single element in the range. So you have an input and outcomes, only one single output. Let's say we have a function that takes any real number as an input and outputs double that number. The doubling function is going to be a function by its very nature, since every single number only has one single number that's double of it. If we call the doubling function f, then taking any real number x and putting it through f, we write that as f of x, is going to be equivalent to taking that number x and multiplying it by 2. Therefore, f of x, the action of f on x, is going to be equivalent to 2x. In general, a lot of functions over the real numbers are going to be easier to manipulate if described in algebraic form, like in the example before. It becomes easier, for instance, to see where a specific x value gets mapped. If we try to see where the value 3 in the domain gets mapped after applying f, then we can simply calculate that taking 3 and applying f, that is f of 3, lands us at 2 times 3, or 6. When we are dealing with real numbers, another way to represent a function or a relation is a plot. It's a visual reminder of sorts, and also helps us spot the main traits of the functions. Say, the oscillation of a sine function, or the peaks and valleys of polynomials, or even circles. When plotting relations or functions, a convention applies. We represent the input of the function on the horizontal axis, the x's, and the output on the vertical axis. For example, on the previous BlackBerry stock function, each date is represented horizontally, since the date is the input, while the output, the price, is represented vertically. What a plot also allows us to do is to distinguish between relations and functions easily through a device called the vertical line test. In a function, each and every single value in the domain, each and every x value, can only be bound to a single y value. The test therefore goes as follows. Take every x value in the domain, then check if there is more than one corresponding y value by drawing a vertical line for that x. If there are multiple y values for a given x, the relation fails a vertical line test, since there are multiple y values associated to a single x. There are multiple outputs for a given input. In this instance, this relation fails the vertical line test since there exists an x value, many actually, for which we get two separate y values in the range. The Blackberry relation passes the test and is therefore a function, since for every single date in the domain, we can draw a vertical line and only one single price comes out. Overall, functions and relations can come in all sorts of forms, be it pretty vanilla or pretty exotic. Their study, be it via the tools seen here or more advanced tools, gives us a good deal of understanding of the world. They are, after all, actual representations of the links we find all around us on a daily basis. Thank you for watching. If you have any questions or comments, make sure to address them to me below. Otherwise, make sure to check the included functions, relations, play with them, and make your own. Weirdly enough, messing around is generally the best way to learn things and to get a feeling for how they work. Good luck learning forward!